In this lesson, we're going to learn how to write the equation of and graph a circle. Notice this time we have two asylums. The x-coordinate of the center is in an asylum and opposite, and the y-coordinate of the center is in an asylum and opposite as well. Also, notice that this equation is not solved for y. It is set equal to r squared, where r is the radius of the circle. Our essential question is exactly what I stated as our objective. How are we going to write and graph equations of circles? Our first example, we're given the center and the radius, so we put it into the asylum, both of them. The x-coordinate goes in and becomes opposite squared, plus the y-coordinate goes in and becomes opposite squared, equals the radius squared. That's the equation of the circle. To graph the circle, you plot the center. You plot the center as the point you are given, not as the values that are in the asylum and not normal. Plot it as the normal center. And then from there, you use the radius to find 4 points that are actually on the circle. Our radius is 5, so I'm going to go 5 to the right, 5 down, 5 to the left, and 5 up. And then you will connect those 4 points as best you can in a circle. This is not a square, so do not make sharp lines between them. Try to make a rounded, circle-ish form. Sometimes mine end up looking a little bit more like a football than a circle, but do the best you can to make it look like a circle. We are also told to identify 4 points on the circle. So we're going to identify those 4 that we plotted. My first point is 4, 2. My second point is 9, negative 3. My third point is 4, negative 8. And my last point over here is negative 1, negative 3. Notice that all 4 of those points have one coordinate in common with the center, either the x-coordinate, if it's vertical from the center, or the y-coordinate, if it is side to side from the center. Example 2, we're given the equation and we need to identify the center. So we take that value that is with the x, make it opposite. Take the value that's with the y, make it opposite. That gives us the center of our circle. To identify the radius, we take the square root of the value that our equation is equal to. Square root of 9 is 3. Plotting the center, 1, negative 3. Make sure you plot the center that you pulled out of the equation. Our radius is 3, so we will make points 3 units away from the center, up, down, left, and right, and do the best we can to make a circle-ish type shape. And finally, we'll identify those 4 points again. We have 1, 0, 4, negative 3, 1, negative 6, and negative 2, negative 3. Those 2 were some basic examples of how to work with an equation of a circle. Now we're going to get into something a little bit more challenging. We're given a point on the circle as well as the center, and we need to write the equation. Given the center is helpful, but we also need the radius. So to find the radius, which remember is the distance from the center to a point on the circle. When we're talking about a coordinate plane, it would be helpful to use the distance formula. As a reminder, you take your x values, subtract them, and square it. It comes from Pythagorean theorem. Add that to, take your y values, subtract them, and square it. Because we are squaring our subtraction, the order you subtract does not matter. The square will cancel if it's negative or keep it if it's positive. In this case, our x values are 3 minus negative 1. Our y values are 4 minus 2. 3 minus negative 1 is 4. 4 squared is 16. 4 minus 2 is 2. 2 squared is 4. So we have a radius that is the square root of 20. Putting that into our equation, we would have x. The negative 1 goes in with the x and becomes opposite, plus y. The 2 goes in with the y and becomes opposite, squaring each of those. And then we would have equals the square root of 20, which is our radius, squared. Simplifying that, we would still have our x plus 1 squared. We would still have our y minus 2 squared, and the square root of 20 squared would be 20. So that gives us the equation of our circle. In order to graph it, it would be helpful to know what the square root of 20 is as a decimal so we can approximate those points on our graph. The square root of 20 is approximately 4.5. Rounded to the nearest tenth when we're graphing is all the accuracy that you would need. Starting off by plotting our center of -1, +2, and then we will go 4.5 units away from our center in every direction. And connect our points. Your U-Try question is giving you the endpoints of the diameter. So think about how to get the radius from the diameter. You will also need to think about how to get the center from the diameter. Think about the fact that the center occurs in the middle of the diameter, and how do we find a midpoint on a coordinate plane?